afternoon, everybody. Rob Schluter, co-founder of Element One Corp., which developed the underlying methanol to hydrogen generation technology. And over the last year, I'm now the managing director of E1 Marine, which I'll talk about a little bit more. It struck me as I was coming under the pier here today that early in my career, about 30 years ago, I was a naval engineer in the Navy. And when I left the service, one of the first positions I interviewed for was at the Victoria Clipper, just a couple piers away, as an engineering officer. And it's like, that was the ferry industry. And here we are 30 years later, I'm circling back, and it just kind of struck me today. So thank you for coming and learning more about this for the ferry industry. Oops, wrong way. There you go. So E1 Marine. So who is E1 Marine? E1 Marine is a joint venture that we started about a year ago that followed about 4 years of inquiry we were getting from the marine industry in regards to methanol, future fuels, and technology to extract the hydrogen from those future fuels. And so we formed the joint venture a little over a year ago. Ardmore Shipping Corporation, which owns a fleet of chemical tankers, they're based out of Cork, Ireland. And the other company, Maritime Partners, which is a leader in the inland waterway space here in North America, and has a very significant portfolio of towboats and barges here in North America, and is also going to be the owner of the Hydrogen One vessel that you're going to learn more about here in a little bit. Essentially, our vision as a company is to commercialize this methanol to hydrogen generation technology for the marine space in a number of different platforms. And so we'll talk more about that here in a moment. So you've heard a lot about hydrogen, you've heard about methanol, and the fuel cell is very, very attractive to this industry. And you've kind of gotten the surface of it here, but from a pollution standpoint and a greenhouse gas point, it's really an ideal method of creating electrical power. It has no emissions other than the water, as Dave was indicating there. You also have a very high efficiency relative to any kind of internal combustion engine. It's a static chemical process, very, very few moving parts, just a couple of moving parts in the system, and it has a very, very high system efficiency. That translates from an operator's perspective into a decreased operational cost. There's very little maintenance that has to do, so that affects the normal maintenance you would have in maintaining a diesel engine. There's very little of that in regards to the fuel cell. And it's also scalable and modular. Think of a server farm. A fuel cell is a stack, and you can put them in a rack system, and as you scale, you just add more stacks to your scale. And then over time, that hydrogen density continues to increase. But that's the reason why it's such an attractive platform for the marine industry, is because of its emission profile, but also these other attributes. The challenge, however, is on the hydrogen side, and Dave was talking about that, and that the logistics of transporting that hydrogen make it really difficult from an economic standpoint to deploy it in any significant way. And when you get into the mobility side, so marine, truck, cars, things of that nature, it really has significant limitations in regards to range. So you've got the significant hydrogen challenge that is slowing the adoption of this attractive power source that's in the marketplace. And without some significant change in how we address the hydrogen issue, it's really going to slow that adoption. And so that's what we bring to the table is people come because of the fuel cell. They come because of the future fuel they've landed on is methanol is the most appropriate for them. What E1 Marine brings is a technology to extract that hydrogen and really accelerate the adoption of the fuel cell power economy. So I'm just going to kind of gloss over this slide around methanol, but it has a number of attractive properties. It's a very hydrogen-dense fuel. It's low carbon. It has a renewable future, just like you'll hear about renewable hydrogen or some of the other future fuels. When you look at that total well-to-wake, well-to-wake carbon intensity, it has the same profile, and if you add carbon capture to it, you can actually get into the negative carbon emissions. One of the questions we had leading up to the conference is for people who are unfamiliar with methanol, what is its general availability? Right now, it is the number 7 traded chemical commodity globally. It's used in all kinds of products. If you use engineered wood products, you're going to find the methanol is the adhesive, and it's in formaldehyde. It's in the windshield wiper fluid in your car. It's all over the place, and it's bunkered in over 120 ports globally. So it's already in the infrastructure of many of our global ports globally. And so really the only issue with methanol is that last mile is just connecting it to the vessel, and that's all it's going to take is some demand of the methanol, and that's an easy pathway to go from the bunkering facilities in the ports onto the vessel itself. And to help support the growth of that, you've also got this methanol fleet that is growing steadily. You've heard a number, I'm sure you've seen a number of the news wires in regards to vessels being put that are being added to the fleets out there globally, and some of the larger marine companies have made announcements here recently in regards to expanding their fleets using methanol as their fuel of choice. When you start to look at the economics, and as you reach out to your preferred provider, whether it's the architect or the system integrator or to us, you're going to come into kind of the cost side and the range side, and all of it kind of folds into this slide right here, which is, why methanol? And it's really about the hydrogen density. How much range can you get? Can the vessel operate in its normal and traditional operational profile? With methanol, it compares very favorably to the other alternatives out there, and in this case, it's going to be ammonia and liquid hydrogen. It has a much higher hydrogen density than liquid hydrogen, and ammonia it's comparative. But when you look at adding the water to it, because the feedstock that it's called fuel reforming, is actually 1/3 water. So we mix the methanol in the water, and then that gives us the additional range you would get out of your vessel. And obviously, the water has a very low OpEx cost, which helps impact the total cost of deploying this feedstock into your fleet. So let's talk about the technology itself here. And so the technology is a methanol fuel reforming system where essentially we take methanol and water and go through a fuel reforming process. This is known technology, been out there for many decades here, but essentially under heat and pressure, and using catalyst, a standard industrial catalyst, we take this liquid feedstock and turn it into a gaseous feedstock. And then we have proprietary technology that essentially works on a pressure differential, and we extract pure hydrogen from that gas stream, kind of like water through a sponge. And so we're able to supply the pure fuel cell grade hydrogen downstream that the fuel cell can pull from the buffer tank. And economically, we use the excess gas there to create the heat energy we need for this reaction. It's a very simple process, but I say that with caveats because it's taken Dave and many of our engineers more than 30 years to make it super simple. When you see it, it is believing it. There's no moving parts or very few moving parts. There's virtually no sound. There's no lights flashing. It does one thing really, really well, which is turn liquid methanol and water into pure hydrogen on demand at the point of use with economics that are about 20 to 25% of what you're going to get delivered hydrogen to your vessel. Some of the value proposition that you're going to get for this is, the zero pollution profile. There's no NOx, SOx, or particulate matter. You get CO2 reduction just using gray hydrogen relative to what you're going to get through an internal combustion engine. There's strong scalability. This is a technology that's dynamic for different applications. We can squash it if we want to put it on a train. We can make it taller if we want to put it on a ship. It's very malleable as far as how we adapt the technology. Just needs to be an application and understanding of the limitations, and then we can kind of scale that technology there. When we talk in a later slide here about the efficiency, our system operates in that low 80% efficiency. Somewhere between 80 and 84% is where we typically operate. This is a very efficient process. The fuel cell itself is also very, very efficient. It's in that 50 to 60% efficiency. So your overall system efficiency is going to be significantly higher than what you're going to do at how you would typically run a diesel genset. Again, some of the value propositions here, if you're looking to compare to how what you're doing today, what is familiar, it's a liquid feedstock. That means there's no special storage requirements other than dealing with how to handle the methanol on board the vessel, which the safety protocols are very similar, but it's liquid. You can carry it in a bucket. There's no pressurizations required, so it's very, very simple. There's existing fuel bunkering in place. It's available globally. It's available locally. There's methanol is made in significant quantities here in the Northwest. It's in Portland, in bunkering facilities. It's available up here in the Puget Sound area. From a safety standpoint with your crews, if they can handle diesel, they can handle gasoline. It's the same safety protocols. There's really nothing unique or special. In fact, and all the characteristics of it is generally much safer than handling any of the existing fuels that are here today. When you start talking to your technical partners about how you want to develop a ship or a new concept for a ferry and deploy these power systems, we can work with any of the fuel cell power systems out there. At their basic level, they all accept the hydrogen, the fuel cell grade hydrogen that we provide, and we've integrated with most of the fuel cell providers out there. And for this project, Hydrogen One, we're working with a company called PowerCell, but we anticipate working at these larger scales with some of the other fuel cell companies you see on the screen. Safety and certifications. So I'm new to the marine industry, but I'm learning quickly. And we've got a great team, and we're working with ABB and Elliott Bay to kind of work us through the certification process. And right now, we have AIP from both Lloyd's Register, who you saw on the panel today, for our M-Series systems. We've also recently got an AIP from ABS and also from the Marshall Islands. And we'll expect to be through kind of the Coast Guard process here by the end of this year. So by any conversations that we would start today, these will be a fully certified system ready to go on board your vessel here by the end of next year. I'm just going to foreshadow a little bit. Alexander Yard is going to come up here and talk about a fully containerized power solution that we're also developing, and so he'll talk about what its application is to the ferry industry. So most of what I've talked about has been about what our technology is, how it's being used, kind of what the process is, and how we're using our units for new ship builds. Alex will be talking here later on about a 300 kilowatt container that we're currently developing that would have application for e-vessel charging for the ferry industry. Hydrogen One. This has been a tremendous path that we've been on here in developing this particular tugboat. We have a consortium. You've heard from Dave Leave, ABB, and Elliott Bay, two key partners here. Rix Industries is a manufacturer of this technology that you're going to hear from next. And then PowerCell. This is a consortium to put this first-of-a-kind methanol fuel cell-powered vessel on the marketplace. Will be on the water in Q3 of next year. All the long lead items have been ordered. It's very exciting. It's getting a lot of attention, and it's very confident it's going to be a resounding success. You'll see it operating in the cut down in the Gulf here at the end of next year. And I think some of the capacities for this, it's essentially a 5+ day range, and it's going to push a couple liquid barges here. As you look at, and this is another slide that you saw earlier from one of the other presentations, perhaps a little more detail, I'm just going to give you a little color here, is that for this particular application, we're doing a couple unique things. You've got the methanol on the bottom, and then you've got a water day tank. And essentially what we're doing is we mix it right on board the vessel. It goes up to the hydrogen generators to produce the hydrogens as it's needed. And then it goes, and the fuel cell pulls off a small buffer tank as it needs the hydrogen. Kind of the cool part of this process, where the one emission for the fuel cell is the water. And what we do is we condense that, capture that water, and put it back on the front end of the system. And so we're just recirculating the water all day long on board that vessel. That gives us the extended range, it gives us the better economics, and it reduces the amount of fuel or water that you need to keep on board for the overall process. The last slide I was going to talk about here is a TCO slide. And this is, any kind of, you look at TCO modeling, there's a number of assumptions that go in here. This was with one set of assumptions that we had for a towboat operation based on what we felt were the operational efficiencies of that towboat. What your TCO is going to be different, and the first thing that we're going to ask you is, what is your operational profile? What is your reality in regards to how you're operating those engines, which will drive an efficiency standpoint? And that efficiency, and the other question we're going to ask is, how many hours are you running it? But that efficiency and how that run, that really drives what your TCO is going to be for your particular vessel. Love to engage you in that conversation. Typically, you're going to find, versus a Tier 4 diesel engine, with the carbon scrubbing that's going on there, somewhere between that 5 and 11 years is where you're going to actually have a better return based on what you're doing with kind of a diesel engine. Now, when we get Hydrogen 1 on the water, we'll have specific empirical data that we can share with you, but everything that we've learned with the partners that we're working with here, we feel like that the economics for what we're doing is actually quite competitive to what exists today. So that's essentially the summary of my speech here. And what I wanted to leave you with is, if you're an operator of a ferry vessel, you came here to basically go low carbon intensity, right, or the go green. What you should think about, what you're going to walk away with, is that you're going to get something that's a much more reliable system. It's a much better passenger experience and potentially a much better economic experience. I encourage you to find out more to see how that can apply to you. And if you are an owner of a vessel, I would encourage you to reach out to your naval architect, your system integrator, and start doing data collection, because really everything starts when you start collecting the data and measuring what you're actually doing and going away from assumptions into what is your reality. But thank you very much for your time, and I very much appreciate your attention as we talk about our technology for your industry.
Again, as Robert said, my name is Greg Baldassarre. I'm with Rix Industries, and I want to thank the Elliott Bay team for inviting us here to talk today. And I'll kind of give you a background first of who is Rix Industries. Rix Industries actually has been around a long time, about 140 plus years. As a company and as a business, our expertise and the solutions we provide are centered around gas generation systems, so generating hydrogen, nitrogen, and now, oxygen, nitrogen, and now hydrogen, as well as precision compression systems, compressing air, oxygen, nitrogen, and then finally cryogenic cooling systems. We provide those systems for all the markets shown here. Of course, my focus happens to be the marine market. The marine market for Rix is one of the largest pieces of our business, both commercial and naval. In fact, on the naval side, Rix Industries provides these gas generation and compression systems for basically the entire combatant force, whether it's destroyers, carriers, or submarines. And those type of applications, we understand the ruggedized environment that these systems have to be in, and we've earned a reputation for high quality reliability in the marine and specifically the naval area that I think has direct application to commercial marine. Rix is about 200 employees size-wise. Our headquarters is in Benicia, California. We have an engineering design center that's very close to that in Fairfield, and then we have a manufacturing facility which is in Sparks, Nevada. And so just what's the relationship with E1? As Dave Edlin mentioned, the business model for E1 as a technology developer of this reformer technology is to license it. Rix is actually a licensor and manufacturer, and our role is to help commercialize it, promote it, of course, and design it for manufacturability. Our second role is, as the manufacturer, we actually build these units, and then finally to help to get it through the regulatory process. And then, of course, E1 Marine has been formed, as Robert mentioned, between Ardmore Maritime Partners and E1 to help promote and drive this technology with their unique access to the commercial marine environment. Let's see. So as we look at the different types of methanol to hydrogen generators, sorry if I wasn't speaking into the mic, but these three hydrogen generators, there's actually, first there's the standalone reformers, which are, we call it our M2H2 130 systems, and that particular system generates about 130 standard liters per minute of hydrogen, which is a little less than a kilogram an hour of hydrogen. That's a smaller system supporting about 10 kilowatt fuel cell system. The M2H2 1800 system produces 1800 standard liters per minute of hydrogen, or 10 kilograms in an hour, to feed a fuel cell system. And then finally, we have on the drawing board a power system which would house the reformers much like the M2H2 1800, combined with fuel cells in a container for containerized power system of 300 kilowatts. In the marine industry, with my experience so far, we've found, it is application dependent. We have applications where we're applying the M2H2 130 in smaller hotel load applications, and then the larger systems in a combination of hotel loads and supporting propulsion. Let's see here. As far as production, we're currently in low-rate initial production. Rix has invested in a manufacturing facility to put in the infrastructure and get the local regulatory approval for producing hydrogen systems, generating systems like this. And currently, we've built about 3 of the 1800 series and about 10 of the smaller series hydrogen generators. And then, of course, for Hydrogen 1, we're anticipating building 10 of those to support that vessel of the larger M2H2 1800s. Right now, the manufacturing facility is capable of producing 3 to 4 of the larger units, and I'd say roughly 10 a month of the smaller units. And we're also, what's not shown here, and I think Robert alluded to, as far as Hydrogen 1, we're also in the process of developing a mixing system. So hydrogen, or methanol, is an excellent carrier of hydrogen and helps to solve those issues with the storage and the logistics of hydrogen. Since one of the outputs of a fuel cell happens to be water, creating a system where you can mix the water to methanol on site, on demand, just like the reformer generates hydrogen, is going to reduce some of the, trying to carry water on the vessel as well as methanol. You can just carry the methanol feedstock. So in conclusion, the technology is proven and it's commercially available today. We're in production. While it's low rate initial production, we anticipate as the regulatory approvals for the system gets adopted, we're going to see increased demand for these reformers, and Rix is able to produce those. And then, of course, the delivery of the Hydrogen 1 reformers we expect by Q2 of 2023.